Hello everyone and welcome to this video of ZAHNER. My name is Sadiq, and in this video we are going to talk about the cyclic voltammetry and how you can set up a cyclic voltammetry measurement. For this we will hover our mouse on IECV icon. This will open a sub window where you will choose CV icon, and here in this window you can set up your CV measurement. In CV measurement we have a starting voltage, an upper voltage, lower voltage and end voltage. So I will go for today with the default values, but you can choose whatever the voltage you want to have. Here you can put a value as 0.5 volt, or you can write 500 M. So both are accepted, and M stands for milli. And then you have some start time and hold time. So these are the measurement times before or after measurement. So you can decide to hold at the start voltage before the CV starts, and also decide to hold at the end voltage after the CV measurements are done. Here we have slew rate. So you can have positive slew rate where the software will then go from 0 to upper voltage first, and you can see here the scan, and then it goes to the lower voltage of minus 0.5 volt. But if I put in this scan minus 100 millivolt per second, then it will go from the starting to the lower, and then it will go to the upper value. So you can define in which direction you want to go. For today we will just stick to the positive scan rate or slew rate values, and afterwards you can define how many cycles you want to have for your CV measurement. For today let's go with 2 cycles, and these are shown here. Also the measurement time is shown here. You can also define how many samples per cycle you want to have. So if you have very slow slew rate, then you should have higher samples per cycle. So for today I can go to, for example, 2000 samples per cycle. And if you are not sure how many samples per cycle you should have for your own CV scan, where you have a different voltage range and a different slew rate, just go to sample per cycle, right click with your mouse, and this will open the PDF, and here you can see a formula. So here you can give your cycle voltage span. So I'm going from minus 500 millivolt to plus 500 millivolt, so that is 1 volt. How many samples per cycle you want to have, and how many slew rate you have. So you have sampling rate, and you can define 3 values, and 4th value will be given to you by this formula. So this way you can properly set up all the parameters here, and then you can do your measurement. Like our IE software, here you also have option to do ohmic drop correction. So if you put a star here and click OK, the system will measure the series resistance, and here I have a series resistance of 10.1 ohm. As I said in my previous video, that when you are doing ohmic drop correction, then as a general rule of thumb, take the 90% value of whatever comes up. So I have 10, so I will take 90%, that is 9 ohm. Click OK, and then you can do the measurement. If we put here 0, the ohmic drop correction will be automatically deactivated. Now for today we want to go from 0 to 500 millivolt and minus 500 millivolt. Let's say I have a new sample and I don't really know how high the currents will be at 500 millivolts and minus 500 millivolt. So the one option is that I go to control potentiostat and I give here, for example, 500 volt, and then turn it on and see how high the current would be. And then I can choose an appropriate current range. But if I expect some current peaks within my CV, then this option is not very suitable. And for this we have this overflow and underflow restart, and you just select these both on and just start recording. We have the highest current range which is selected, and now the potentiostat will do a scan. So we start from 0, we went to 0.5 volt, and now we will go to minus 0.5 volt, and the potentiostat will see the currents are very small but our axis is very large, and it will automatically change the shunt resistance within the potentiostat. And now you see that the y-axis is minus 5 to plus 5 milliampere. Again, the potentiostat make a scan from the starting value to higher potential and lower potential. So it goes to the whole scan range to see that what are the current for the whole scan range. If the currents are too low, it will optimize the current range for you. And once it finds the appropriate current range where it measures the sufficient currents, then it starts recording your CV scan. So now you see it will not stop here, but it will keep on measuring the CV scan. I will just skip to the end of this scan to save some time. The scan is finished, and now we can save the scan. Now here you can check also that your scan is within the range of plus minus 20 microampere. Now you can here provide appropriate current range. So minus 20 micro, so micro would be with U with 20 micro. And now you can deactivate this. And by deactivating this, now the potentiostat will not actively look for the appropriate current ranges and will follow your current ranges. If for some reason you did not set your current range properly, and during the measurement the current exceeds this current range, the measurement will stop. So that's why it's better to have some room between your highest current and the current range which you have decided on. Another very important thing is that if you are working with very, very slow slew rate, so for example, I'm working with 100 microvolt per second. Now the whole measurement will take 13 hours or 14 hours. If I do not provide the appropriate current ranges, I just want to use the overflow and underflow restart. And here I have minus 3 ampere to plus 3 ampere current range. Then it will take the potentiostat very long to validate the correct current range. It may last up to hours. So if you are working with slower slew rates, then it is better to first get an idea about the current range and set the appropriate current range and then deselect these two. So with this, we came to end of this video. I showed you that how you can set different parameters for your CV measurement. In the next video, we will start with the impedance spectroscopy. So thank you for your time and see you in the next video.